Okay, now we move into a curvilinear motion. A curve motion. So curve motion, we need to recall a few parameters. So in canvas, you'll see appendix in the canvas, appendix B. You go and read because it's deal with the vector calculation, like what is the dot products, how you go to the cross products. Okay, so we don't have time to teach you how to do the vector calculation. We assume you already know, meaning vector A multiply B and vector A cross B vector is a different thing. Go and read appendix B. Inside there got exercise, got example. Go and download and read. Okay. Because for linear or in later chapter, you will deal with vector multiplication procedure. Okay, first, same. Just recall rectilinear motion. You deal with, because it moves in a straight line, you deal with S, V, A, and T. Now you deal with curve motion or curvilinear motion. It can be this way, it can be this way. Okay. We are using position as R. The displacement or the position is from here to here. This is called path. Okay, this is called path in the function of time. S bracket T means in the function of time. Okay, this is the first definition for curvilinear motion. And the position. S is path. So in curvilinear motion, S is your path, means distance traveled in the curve. Another rectilinear, you are more focusing on R, which is the radius from the center of the curve. All the curve is actually a circle. So all circle have one middle point or center point. So this is a center point, 0. You will always referring from the center to that dot and center to that dot. So this is the initial position. This is the last position. And it will referring to center of point of the curve, right? So there's a path travel along the circumference of the circle. Okay. So in this second half, you recall that you learn from the mathematics, there's a theta, S, and R. S and R. This is very, very small section of circle. You arrive at S equal to R theta. This one is in radian, right? And how to convert radian from 360 degree equal to 2 pi radian. So this is, you need to call back all this information, right? So for second half, if you deal with curvilinear motion, most of the time you need to recall this S equal to R theta. Okay, now you have the first position vector, which is in R term. This is position for curvilinear position. Okay. What about displacement? Displacement, in this case, they give you this equation. Okay, before I wrap this one, I need to recall your vector vector diagram. Vector 1, let's say A vector. What is vector? Magnitude plus direction. So if your A plus B vector, they are moving in the same direction, you arrive at longer vector, which is the A plus B vector. Okay. Now, when you draw a circle, a vector diagram, let's say you take A plus B. So let's say you have 1x1, not x1, let's say I put A here, plus vector B equal what? You take initial A, continue from arrow here, draw B, then resultant from the starting to the end position. This is the resultant vector. Okay. So same. Resultant will be equal to A plus V vector. You take the same concept, apply to curvilinear motion, because this is vector from center to initial position. You have one vector R, and the final position on the curve, you take center to the end position, which is R prime. You take this one as two vector, you apply the same principle. So basically, you're taking R and taking R plus R prime. You are having, I just draw a random, I draw a resultant, for example. So the equation will be R prime will be equal to start to end. For example, you will always have, okay, maybe I erase this one because it might confuse you. Okay, the diagram here always have start to end vector. This is resultant. So if you look at this vector here, you follow the arrow, because in curvilinear motion, your arrow always pointing from the center to the position. The arrows pointing out. This one also pointing out. Then the changes of the displacement is from this point to this point. Means you draw the red arrow. It's from here to here. The arrow is from here to here. Then you take this one as a vector diagram, and the understanding of this one, R plus start to end. So you try to see the diagram. Can you find the start to end arrow? Means you combine, you can link the two arrows together. So here, how you link the arrow together? This one, from start arrow here. Then at the end of the arrow, there's another arrow following from here, which is a red arrow here. So basically, you take this one plus this one equal this one, because this one is from start to end. Makes sense? So try to like hold on the general principle here, and then in your free body diagram later, you draw according to the motion. Then you link between the concept. That is more important, because all this direction, the yellow color and red color arrow will change according to the question. Okay, when it comes to curvilinear motion, first thing, draw the center of the curve. You can anywhere, as long as you curve in, circle, curve inside is your center. The curve inside is your center. So go somewhere inside the curve, draw an X and put 0 there. Then go into the position, like from the center, initial position, it will give you like 1 and 2. 1 and 2. So you draw arrow from center. This is 1. This is 2. Draw arrow first. Then after that, then you draw the displacement, delta R. Initial position to the end position. This is delta R displacement. So a bit tricky in the curvilinear motion kind of free body diagram. Okay, understand this one? R prime equal to R delta R. Okay. This is the first equation for curvilinear motion. R equal to R plus delta R. Of course, this one is for this kind of motion only, from the top to bottom. But it's flipped. If the question flip, then this equation does not apply anymore. You need to derive from the equation right on the whiteboard here. Okay, if this one flip from bottom to up, then everything will flip already. Yeah. Okay. So you rearrange, you'll get displacement equal to same lah, R prime minus R. So what I'm proposed for your revision, you change the S into curvilinear motion, you change S into R, then later I will tell you this one change to something, this one change to something. All the equation in the curvilinear motion remain, you just change the parameter from S to R. For example, S delta S equal to what? UT plus half what, AT squared, correct? Yeah. So later when you use this equation, in curvilinear motion, you change the S into R, and then U to something, A to something. Yeah, just give you a highlights. Okay, so for average velocity, velocity, you take displacement with the time differential. This one is curve. So your S become delta R time differential of time. So everything is the same like curvilinear motion, like a rectilinear motion, but now it become a curve. So you change the S into R. All the concept is the same. You just change the parameter. So instantaneous, you do the same for rectilinear. So the first equation for rectilinear, you want to find velocity of the particle moving in the curvilinear motion. You take dr equal to dt equal to ds dt. Okay, I highlight with a different color. I will explain on the thing later. Then important, you need to start to draw vector already. So I highlight the first V with the green color. This is the V for the particles from the starting point. And the V, the trick is V always tangent to the curve. V tangent, what I mean by tangent? You move to the center of the curve, 90 degrees from the radius. Yeah, this is important. This concept is important. Throughout the module, every time you see curvature motion, straight away draw a V tangent to the curve. Just use your ruler, go to draw a curve, then use your ruler, draw a arrow there. Depends on the motion. If you go, in this case, you go down. If you go up, then you draw another side. Important. This one, this concept is important. Always draw a 90-degree tangent to the curve for the vector. Okay. Same. How do you draw V for this red dot there? Same. Use your ruler. You know your ruler got edge, right? Go move your ruler here. This is your ruler. Align your ruler with this line. Then draw the line. This is your V for this position. Always tangent. 90 degree to the curve. Okay, this is the basic concept. Basic concept. Right. We move on. Yeah. The first concept important is you know how to draw the vector. This one. Second one, after velocity, we move to acceleration. Acceleration is another interesting thing. You cannot combine velocity and acceleration in the curve. It's a different concept. When you analyze acceleration in curvature, you look at velocity already. You focus on acceleration. You have two vectors. So you see the difference between the two green arrow. If you see the two green arrow, one is short, one is longer, it means there is a change of vector magnitude. If you see this kind of diagram, it means accelerate already. These particles moving faster and faster. So the acceleration is positive value. So again, where is the center of the curve? On the curve pointing inside. The center is over here. Okay. Okay, V and V naught. So same. When I write this one, you should able to relate this one to this one. Okay. Meaning you take V and then you can continue if you want. V prime. This one is your resultant. Change V. No, not this one. This one. Let me go into the. So the equation is the change of velocity vector. This is getting faster and faster. So the magnitude must have some addition of velocity, right? It becomes longer. So V at second position, it must take the initial vector plus addition of vector so that it becomes longer and longer. But you rearrange, you arrive at another equation. Be like that. Okay. The way you draw in the curvilinear motion is a bit different from the normal rectilinear motion. You're always referring to the center of the circle, right? So here, like the one you see on the screen there, okay? So we pull the vector out, and this O prime here actually is on the hodograph with this this is hodograph. The dotted blue one is a hodograph, means it's an imaginary curve. It's an imaginary curve from the fixed point. Means you pull this one, and then you combine them at the fixed point. You will move in the holograph center point there. Okay. Then there is a delta V. So from there, you arrive. So this one is initial from the center to that velocity, center to that velocity. Then this is the changes of velocity. By using this principle, so you take from start to end. This is start, continue. So you take this one plus this one equal to this one. This is the resultant, right? Start to end position. So that's why you arrive at V prime equal to V plus delta V on the hodogram, on the hodograph. And go fast. So average velocity is dv dt as you learn in your rectilinear motion. Again, we apply the limitation of limitation for the derivation. I'll give you all the equation. Okay. So this one, you know, A equal to dv dt. So what you do is that you substitute the V with the R, V with the S. So you know that in here, your A in rectilinear, A equal to dv dt. When you substitute V definition, it actually double differentiation of S and T square. Now you replace your S as R. You replace this one as R because it's a curvilinear motion. So your second definition for V equal to dr dt. Okay, and again, velocity always tangent to the curve, and acceleration always pointing. Second thing, acceleration always pointing inside the curve. Okay, how you explain this phenomena? You imagine you are swinging a ball, and the ball, if the ball can keep inside the circle, if the equilibrium happen, there must be a force pulling the particles inside. That is we call it, there's name for that lah. There's acceleration pulling there's acceleration that pulling inside. If not, then if you let go, you cut the string, the particles will move outside the circle. Okay. So that is how you analyze the collinear motion. This is an important diagram. V always tangent, and then use your ruler. You follow another side of the ruler pointing inside. That is your acceleration. Okay. These are the tricks. Okay. So I think I'm familiar with this one. In vector, X placed with I, identity vector. Y is as with J, Z with K. So if your R is in 3-dimensional, you can write in R equal to X. X means the magnitude of the X direction. You can break into I, J, K magnitude. Okay, so this one, you're familiar, right, with the vector in 3-dimensional dimension? Yes. Okay. So R you can write in vector form, X, Y, and X, I, J, K. There are different presentation. Some textbook, they use bolted with an arrow. In my slides, because I don't like to always repeat this one, so I use the color or bolted color in the next few slides. Now, vector, this vector magnitude is a square root of X, square root of Y, square root of Z. X square, Y square, Z square. This is a fundamental. So in collinear motion, vector magnitude equal to X square plus Y square plus Z square. Means you take the magnitude of the X direction square, Y direction square, Z direction square. Okay. You find the magnitude, which is the length of the arrow. Vector also have direction, right? Direction of the vector given by position. UR equal to position divided by magnitude of R. Okay, so this one you learn in your vector chapter. Okay, so direction of R, you use UR, or you can just write direction of vector equal to position divided by magnitude. What does it mean? Position R is this one. You take this one divided by the answer of this square root. Okay, take this one divided by this answer. Okay. So again, you go to the 3-dimensional. If this is the question, you seeing the particles is moving here like that. This is a curve. First thing you draw velocity is the tangent direction. Go use your ruler, point to the center of the curve. Because this one is 3-dimensional. You just find somewhere that if this is a curve, the center is somewhere here. So what you do, you just mark a center here, use your ruler, and then you draw velocity at the tangent circle there. This is your V. V equal to dr dt. Again, don't write ds dt because this is a curve motion. Replace the s in the rectilinear with the r. Okay, so you put that dt equal to xi plus ij and k and so on. Okay, so I just back into that. This is just a short. Again, you see this one in the appendix B. Go and study it. So if you differentiate xi, x is a constant value or scalar value. I is the vector identity. So if you differentiate, you need to use chain rules. There's a chain rule in mathematics. All right. So you differentiate this one, then this one, plus pull the remain something, and then either differentiate something. All right. This is a chain rule. All right. So if you never heard of chain rule, go Google and find out how to do chain rule in differentiation equation. This is differentiation. Right? How to do chain rules in differentiation equation? Go Google and find out. Okay. So when you do chain rule like that, the last identity here, the I is a identity magnitude is always along x. When it always along x, this becomes 0 because it doesn't change over time, right? This I, it doesn't change over time. It's always pointing this way in x direction. So this one's 0. You take out this one for the first one. You do the same for y, do the same for z. You always take out the j or k second half. You arrive at this one. You take out, you arrive at this equation. You arrive at dx over dt I plus dy dt j dz dt k. In short, what is dx dt is a velocity in x, dy dt is a velocity in y, dz is a velocity at z. But this one comes with the vector identity. How to find the magnitude? Square root this one, square this one, square this one, square this one, add together, square root, you get the magnitude. How to find the angle? Take this one, divided by the magnitude of the velocity. Okay. Okay. Something like that. Okay, so this is a vector chapter, calculation there. Just to highlight again, V always tangent to the path. Always tangent to the path means you use your ruler, find the center, draw the tangent arrow. Okay. What about acceleration? Still remember direction of acceleration? Pointing inside the circle of the curve or the curve. So always pointing inside. Okay, same. Acceleration derivation also same. A equal to dv dt, but now your V is the one that you see just now. So dv dt become acceleration, same, you change V to A. Again, it's a vector, so you get AX, AY, AZ in IJ. Same because this is vector. Square this one, plus square this one, plus square this one, square root. If you want to find the direction, take this one divided by the magnitude. Okay, so this one I just randomly I pick one direction. I assume that the curve over here is pointing here, but if you draw here, also correct. Okay, you just need to point inside the curve because this one is in 3D, so you can draw as long as it's inside the curve. Okay, so the rest is the same. The concept is you take magnitude divided by the vector divided by the magnitude. Okay. Just highlight A is not same as V and so on. Okay, so we stop here. See you next week. We will recall this one next week and do one exercise.